So we're going to take a look at cylinders and particularly the volume of cylinders and how to get it and why the formula works and all those kind of things here. But before we get into cylinders, let's take a step back and look at circles real quick because the cylinders formulas are really based off of that of a circle. So we know that a 2D circle, so nothing, a circle that doesn't have any height or depth. If it has a radius of 5, we know that the area formula for a circle, any circle, is pi times r squared. So that's the formula for any circle, big or small, any 2D circle. It's pi times the radius squared. In this case, it's 5 squared, so it ends up being 78.5. Now, what a cylinder is basically a stack of circles on top of each other, one after another. So if you could imagine a circle with essentially a height of very small amount. So not necessarily 0, but just a very small amount. So if I take one of these circles here and plop it there, being the same circle, that obviously has an area of 78.5. So this circle right here has an area of 78.5. Now, if I drag another circle on top of it, I'm going to kind of skew them a little bit so you can see. If I drag another circle on top of it, now I have two circles on top of each other. So the total area, or the total space between those circles, because every circle has a flat edge on top and bottom, the total area there would be 78.5 times 2, because it's just two circles. If I dragged a third circle on top of there, the total space between those circles would be 78.5 times 3. And if I dragged another circle on top of there, we can kind of get the idea here, that total area would be 78.5 times a total of 4, because I have 4 circles. So each of these circles has kind of a height of almost 1. Okay? And if I drag infinitely many circles on there, so if I put another one there, and then another one, and then another one, I'm going to kind of make this a slanted cylinder, but it all works the same. And another one, and another one. If I just keep putting circles on and on and on and on and on, I suddenly lose track of how many circles there are. So instead of saying 78.5 times h, I'm going to say, or sorry, instead of saying 78.5 times 4, I'm going to say 78.5 times h, where h is simply how high this stack of circles is. So if I don't know how many circles there are exactly, I'm just going to measure how high the stack is, and that will be how many circles there are, quote unquote. And that's where you get the volume formula for a cylinder. The volume formula for a cylinder is pi r squared, that's one circle, times h, because there's going to be h circles on top of each other. Or the stack of circles is going to be h units high, which is where that h comes in. So it's not just that we threw these things together at random and saw that they worked. It was a deduction from what we knew about circles already. We took the circle area formula. We saw that a cylinder was basically a stack of circles on top of each other, and so we got the volume formula pi r squared h. So if we put that into use here, we have this cylinder here, and again, the formula is not too hard to use because it's a very small formula. We see that in this case, my radius is 5 and my height is 12, kind of like I was doing before. So my volume would be pi times 5 squared times 12, just to be very careful to make sure you square the right number. It's not uncommon for people to mix around their height and their radius, just because if you're not paying attention, it's a very easy mistake to make. So if I use 3.14 to substitute for pi, or you can use the pi key in your calculator if you're using that, you get about 942 centimeters cubed. Remember, volume is in cubic units because, unlike area, volume is basically saying how many 1 by 1 by 1 cubes would fit into a shape. So how many 1 by 1 cubes would fit into a cylinder of this size? Well, 942 of them. Whereas area, like we did before with the circle, area is how many 1 by 1 squares will tile or will cover an object. So area is about covering an object with squares. Volume is about filling it with cubes. That's why we have area in square units and volume here in cubic units. As far as the formula itself goes, though, again, not too hard. Just a few multiplication tricks to do. Let's try another one here. Sometimes the cylinder will be given on its side. So you always have to remember that the height of the cylinder is the line that connects the two circles. So the height of the cylinder is the line that connects the top circle to the bottom circle, or the left circle to the right circle if it's on its side. So in this case here, when I'm doing my volume formula, I would do pi 2 squared, because that's my radius, times 6, because that's my height. And I'll go through the formula again here. I would do 3.14 for pi, or again, you can use the pi key if you have that in your calculator. And then you times it by 2 squared and times it by 6, and you get 75.36, and again, that would be inches cubed. Now, some people will leave your answer a little bit differently. Some people will leave it like this. They'll say, okay, pi times 2 squared times 6. Well, I know that 2 squared right here, that's 4. And I know that 6 times 4, right here, that's 24. So I'll leave my answer as 24 pi. And this is not technically incorrect. If you type that into your calculator, 24 times pi, you'll get the same answer we got. But it's just the way people sometimes leave their answers, because pi tends to make answers very nasty to look at. And they're usually really nasty decimals. If you use 3.14 as an approximation, it's usually a little bit easier. But sometimes they'll just leave the pi in the answer without multiplying it through. That way, if they do have to do some operations on it later, that it doesn't muddle the number up too much. So if you see the answer like that, know that they're not skipping a step, it's something different. It's just they're leaving their answer in a different form. Kind of like an unsimplified fraction almost. And lastly, let's look at a word problem here. Just make sure we fully understand this. So a water barrel holds 300 cubic feet of water. If the radius is 4 feet, how high must the barrel be? So this is actually asking us to do it in reverse. So if I draw a little picture here, we have a water barrel. I'll do my best to draw a picture. I'm not the best artist, but I can usually make do with basic geometric shapes. Okay. So we have a water barrel there. I'll draw little curves of the wood if you want. Okay. So there's our water barrel. Here's a little spout to get the water from. Okay. Don't necessarily need to draw the spout in there, but if you want to be a little artsy, you can. So it says the radius is 4 feet. So I'm going to go ahead and draw that in so I don't forget that. So my radius from center to edge, and again, you can go from center to any edge. I'll go up here. My radius is 4 feet. And I know that my volume, so I'll put V here, my volume is 300 cubic feet. What I'm asking for is actually the height. So I actually know my volume. I want to know how high, or in this case, how long if it's on side, does the barrel have to be in order to hold that much water? Well, I'm going to go ahead and go back to my formula, which I'll write down again here. Very simple formula. Volume equals pi r squared h. And I'm going to plug in the numbers that I know for the variables that they represent. So I'll leave pi as pi because I don't know what pi is. Well, actually, I do know what pi is, but it's not a variable, so it's kind of like a number, so I'll leave that there. I'm going to replace the V with the 300 because I know that my volume is 300. It told me in the problem. Volume is 300 cubic feet, so I'm going to replace my V with 300. I'm also going to replace my R with 4 because it says my radius is 4, so I know my R. What I don't know is my height here. I don't know my H. That's what I want to solve for. So I'm going to do what I know about equations and solve this like I would any other equation. So if I go through here, 300, I'll bring that down for right now. I won't do anything with that. Pi, I'll bring down. 4 squared, I know is 16, so I'll write times 16. And I'll write times h. I'm going to give myself a little bit more space here. Okay. Now here you have a few options. Because again, the goal is to get h by itself. So if I box in the variable I want to get by itself, I'll box in my little h here. I want to get that h by itself. Right now, there is a 16 timesing it, and there's a pi timesing it. Again, the pi is a little further down the problem, but it's still timesing to the h because there's no addition or subtraction or division sign. So both the 16 here and the pi here are multiplying to the h. I want to move them away from the h. I want to solve for h. I want to get h by itself. That way I know what h equals. Well, I could divide by 16, and then divide by pi, I could do it in 2 steps. Or because they're both being multiplied, a lot of people will do this. They'll say divide this entire side by 16 pi and divide this entire side by 16 pi. And again, sometimes they'll write it the 16 first and the pi second. And again, it doesn't matter the order because it's multiplication, but sometimes they will write it in reverse order. And what that does is it cancels out my 16 over here, and it cancels out my pi over here. Again, like we would a fraction, if there's same numbers on top and bottom, they cancel out. And it leaves me with just h, which is what I wanted. Then on the other side, it gives me some nasty little decimal because, again, it is involving pi. So again, I'll use 3.14 to approximate it. So I'll do 300 divided by pi, and then I'll do I'll do that answer divided by 16, and I get 5.97 if I round it off to 2 decimal spots. So my barrel has to be 5.97 feet high in order to hold that much water with that much radius. So sometimes you will need to work the formula in reverse to figure out a missing piece. So instead of figuring out volume, you might be figuring out height, or you might be figuring out radius. But in either case, all you do is you write down the formula as you remember it. You plug in the numbers for the variables that you know. You leave the variables you don't know alone, and solve for them after you have everything plugged in. So just make sure you remember the formula, and we all should be good. Hope you enjoyed the video. Have a good day.